So let's look at this example now. I give you the polar function r equals theta, which is a very simple polar function. And actually, I give you the polar curve here, which is like a spiral from the origin, right? And I would like to ask for the shaded area, which is shaded here, right? And please recall that the area formula is half times the integral of r squared d theta, and you have to tell me the angle here because the polar function is given already. I think this case is fairly simple because if you think of it as the start point, because of the fact that when the angle is 0, the polar function gives you 0, which means that the origin is the starting point. You can think of it like this. And gradually, when you trace along the curve, when the angle gradually increases, you are basically going along the curve like this. And at this point, it is exactly the point where the angle should be pi. When the angle is pi, the r is actually pi again. And that's the marking of this point, like pi and pi for both the r and the theta, right? And basically, now it's an easy calculation because you can actually compute the area as half times the angle of the integral from 0, which is the starting point, up to pi. And for the polar function r square, which is essentially theta square because of the fact that the polar function is very simple. So basically, we can do this computation now. So basically, that's the final answer, which is the area of the shaded part of this problem.